In example number 4, we're going to take a look at how we can analyze all of these data points to see if they approximate a normal distribution, and then we will also see what percentage of these cell phones will live for more than 3 years. So I've taken the liberty of entering all these data points into list 1 already. There's 60 of them. You don't need to sit here and watch me do that. So I've entered those. And what you're going to do is, so we're going to go second stat, math. We want to find the mean. Oh, that's not what you want to do. Clear, to enter. All right, second quit. So always start from this screen. So second stat, math. We want the mean. We want the mean of list 1, and we get 2.526. So let's record that. Mu equals 2.56, or 2.526. This is a 5, really it is. All right, now we're going to find the median just to see if it's close to our mean. And if it is, that is a good hint, at least, that our data will be normally distributed. So let's find the median of list 1, and it's 2.55. So that's pretty close to our mean. So that kind of tells me we're headed in the right direction anyways. Now we can graph our data points. We're going to have to do a little bit of work to make that look proper. So we're going to hit y equals. Actually, we're going to hit second y equals. And we're going to hit enter on plot 1. And if it's not already there, you're going to hit enter on because we want to see it. And we're going to create a histogram. So we're going to do the bar graph. So you're going to move your cursor over and hit enter on the bar graph. Your X list should be list 1, or whichever list you've put all your data points in. And now you can hit graph. Now, you might have to change your window settings. So I chose these. Window X min is 0, X max is 4, right? None of our data points are above 4. X scale, I just chose 0.1. That's entirely up to you. Y min is 0. Y max, I chose to be 10 because I don't think there's more than 10 data points in any one given spot. And so now I hit graph, and it'll give me a histogram, a bar graph of my data points. And for the most part, it sort of looks like that bell curve. So it would be fair to say that these data points are normally distributed. It's not exact, right? There's some variation in here, right? There's a big dip here, but it's close enough for our intents and purposes. So if we look at part B, what is the likelihood that it will last for more than 3 years? Well, we kind of need to find our standard deviation. So let's do that. So the standard deviation for list 1 is 0.49. So Shirley's worried about a 3-year cell phone. So if we look at mu is 2.52, 2.53, if we were to add 1 standard deviation, we would have roughly 3 years. So if we flip back to here, 50% of our data is going to be on this side here, under the curve. So we're going to, that 3 years is one standard deviation above. So we're going to take this 50% and add it to our 34%. So 50, 56 to 0, plus 34 is 84. Now this tells us 84% of those phones are going to die in less than 3 years. So that means there's a 16% chance, right, 100 minus 84, a 16% chance that that cell phone is going to last for more than 3 years.